Okay, so in this video, I want to look at density and then relative density. So first of all, let's look at density. What is density? So when we talk about density, is the definition is density density of a substance is the mass per unit volume of a substance. Okay, so density of the mass per unit, of a substance is the mass per unit volume of the substance. Okay, so it is just finding so mathematically density, let's use different colors and make it more. So mathematically density is equal to the mass of a substance, okay, over the volume occupied by the substance. And density, we always represent it by rho, which is equal to m over v. So we want to know how heavy an object weighs, or the quantity of matter in an object in relation to its volume, the size, the three-dimensional space occupied by that substance. So this is density. So if you're able to get the density, you are done. The unit of measurement for mass is kilogram. That is the standard unit, and then that of volume is meter cube. So the unit of density is kilogram per meter cube, which is the same as kilogram per meter cube. So this is the same thing. So this is the unit of measurement for density. This is the unit of measurement. So whatever you want to find, first of all, you must get the mass of it. You must get the mass of the substance or the liquid or the solid or the gas you want to find. Its density, first of all, get the mass of it, and then you can do so by means of electronic balance or chemical balance or beam balance. Chemical balance or beam balance, there are lots of them, okay, or beam balance. Okay, so when you are done, you must get the volume of what you're looking for. So mostly for regular solid, there are specific formulas we use. Let's consider that one here. So something like a cube has a formula for in terms of density as L times what? L, that is length times breadth times height. But because a cube has the same size at each dimension, it will be L cube. And then we have cuboid. Cuboid has a formula of length times breadth times what? Height. Okay, so by this formula you can find the volume of a cuboid or rectangular solid. That of a sphere. Let's look at that of a sphere. The sphere, let me write it well. A sphere have a definite formula as in 4/3 r square, that is pi r square. So 4/3 pi r cube. So we want to find the three-dimensional space. That of a cone. A cone is equal to so we look at that of a cylinder. So 1/3 of the pi r square, h the height. So this is a cone, an example of a cone. Then that of a cylinder. Okay, this is a cylinder. So that one to cylinder Formula is pi r square h. So for a regular solid which has a fixed or proper shape, we'll be able to use definite formulas to find its volume. For that of a liquid, we use a measuring cylinder, measuring beaker, and the rest to find the volume of a liquid. And that of irregular solid, we use what we call Eureka can method. Eureka can method. So let's look at that one quickly. Eureka can, let's get space. Okay. So before you get a volume of irregular, so this is our irregular solid. First of all, I have to, if you are using a measuring cylinder, it always comes in this form. It has a graduation or a calibration along the vertical height, and then you first of all fetch water or any liquid you want to use, and then label the volume V1. When you are done, just tie a rope to the irregular solid and gently lower it into the measuring cylinder, which has its volume been taken as V1 already. And when you do so, so this is our irregular solid. You see that the volume will rise, and in this case we take the volume as what V2. But when you are taking the volume, make sure that you take you read it, you see the inward, the curve, the meniscus is always curve inward. You read at the bottom, okay? You read at the bottom, because if you read it here, the whole of this side is not covered with water or liquid, so you will not get accurate measurement. So when you are done with this, all you need to do is just subtract V1 from V2. That is the initial from the final. So the volume of the irregular solid, so volume of the irregular solid will be equal to V2 minus V1. And then if you are finding the density, and then maybe you have found the mass to be M, you just have that your density will be equal to rho equal to M over V2 minus what? V1. You are done with this side. So this is how you can find the volume of irregular solid, but with a definite formula. I just have to use a definite formula, find the volume, and then introduce your equation as V M over what V, and then you are done with it. So density is basically this. Density is basically this. Now let's look at relative density, something small about it. Relative density. So relative density mostly represented by R dot D is equal to the ratio, or is the ratio of the density of a substance to the density of water. So finding the relative density, RD, is always for a substance. So we want to find the relative density of maybe oil, liquid, any liquid. We compare it with water. So RD mathematically is equal to density of substance over density of water, and this will be equal to, so RD, this implies that RD is equal to density, that's so rho of substance over rho of what? Water. And basically this is how you can obtain the density of a substance. So first of all, you must get the density of the substance and then the density of water, and then you compare. So imagine we have a density of maybe water. We know that in grams is 1 g cm cube, and then that or another density of another substance which can be maybe 0.8 grams per centimeter cube. Okay, so if you want to find the RD, this will be equal to RD is equal to 0.8 over what 1, which will be equal to actually 0.8, but because the units are the same, they will cancel out. So here you have grams grams per centimeter cube, and then grams per centimeter cube. So this will cancel, and then you have it. So relative density is actually dimensionless or has no unit. That is it. So that's just a brief understanding of density. But before we go, let's look at this one quickly. Okay, so let's get some space now before we go. Good. So we can also express relative density in this form. So we are saying the density of substance over, so let's say RD is equal to density of a substance over density of water, which is equal to mass of a substance over volume of a substance, and then mass of water over volume of water. So whenever we are comparing relative density, we always compare equal volumes. Okay, equal volume of water to equal volume of substance. So we have m s over v, so divided by mw over v. This will be equal to ms over v times, so we have to reciprocate this side, and then we'll have v over what ms. So the volume are always the same, so this will cancel. So we'll have mass, sorry, this is water, mass of substance over what mass of water. So another definition for relative density is the ratio of the mass of any mass or the volume of the mass. Okay, so the mass of any volume of a substance to the mass of equal volume of water. And so that is another definition for relative density. So we have RD to be equal to mass of substance over what mass of water. This is another equation for relative density. Thank you. Subscribe to this video and hit the notification button to receive notification whenever I upload new videos. Thank you. Subscribe.